Hi everyone, happy chronication. We're going to be doing problem 11-12. So, as you guys have seen in the last video, it's pretty straightforward, and here is just another time for review. Taking a look at the question, let's talk about what we're working with. We are working with 25.0 grams of nitrogen gas, and it's going to react with 5.00 grams of hydrogen gas to create ammonia, NH3. The question is, how much NH3, how much ammonia could be produced from this reaction? Now, when it comes to stoichiometry, remember kids, first and foremost, you always need to do this. You need to figure out what is going on in this question. In other words, what is the chemical reaction going to look like? Not just the chemical reaction, what does the balanced chemical equation look like? So doing the math, you should be able to know how to balance an equation by now. You'll find out that the reaction is balanced as 1 mole of nitrogen gas reacting with 3 moles of hydrogen gas to produce 2 moles of ammonia. Now with that said, we're moving on to step 2. The balanced equation is set, and now we're going to use that to our advantage to figure out the answer to this question. Let's first start off with this little moment here. In a magical Disneyland scenario, every reactant is unlimited, but in reality, one of these reactants are going to run out first. The goal is to figure out which one that is. And we're going to actually do 2 calculations, one for reactant 1 and the second for reactant 2. I might as well just start off with nitrogen because that's the first thing that I see. And here we go. Starting off with 25.0 grams of nitrogen gas. I need to convert my grams to moles of reactant. And now I have moles of reactant. I need to convert moles of reactant to moles of product using that mole ratio that I figured out for the balanced equation in step 1. Now that I have moles of my product, I need to convert that to grams of product using the molecular molar mass that I need to calculate. Now, all the units should be able to cancel out. Grams cancel out grams, moles with moles of my reactant, moles of product to moles of product, and now I have grams of product. I feel justified to crunch the numbers, and there I go. 30.4 grams of ammonia if I went through with nitrogen gas. Well, what about the other one? It's the same process. Grams of reactant to grams of reactant, moles of reactant to moles of reactant. I end with moles of product. Cancel that out, I get grams of product. And now I have a value for grams of ammonia. So what am I going to do with this? I'm going to compare these 2 values and I go, which is the one that produces the least? Which one's greater, 30.4 or 28.2? The one that's the smallest value is that one right over there. It's 28.2 grams of ammonia. Why does that matter? Because if you look back at the equation, look back at the question, it asks, how much ammonia should be produced in this reaction? The reality is, it's going to be the one that's going to run out first. Hydrogen produces the least amount of ammonia in this reaction. So, therefore, in reality, this is the actual amount of ammonia that we're going to make based on this chemical reaction. Box your answer, make sure you check your sig figs, and you're good to go. That's question 11-12. Now we're going to move on to 11-13. It's pretty much the same concept, but there is something that we need to kind of take note. Let's take a look at this let's take a look at this question together. Nitrogen gas can be made from passing gaseous ammonia over copper 2 oxide at high temperatures. Other products include solid copper and water vapor. If 18.1 grams of ammonia react with 0.145 kilograms of copper oxide, then how much nitrogen gas can be formed? Notice I emphasized something in that last sentence. 0.145 kilograms of copper oxide. That's going to come up very soon. Specifically with this. I think you guys know what we're going to do with this, but let's see if your ideas match what we're going to do on the whiteboard. So step 1, obviously same as before. Figure out the balanced chemical equation. Boom, right there. As we can see, it's pretty much balanced. Oh, now it is. Now it's pretty much balanced. Now the thing is, what do you do with it? Same as before. What I will say is this. When it comes to a chemical reaction that has a lot of products, you have to remember what the goal is in mind. The goal in mind is to figure out how much nitrogen gas is formed. So you can do all the products that you want, but to make life easier, find the one that you want to focus on, which is nitrogen gas in this reaction. So with that said, pick any of these 2 reactants, doesn't really matter. I just chose NH3 simply because it's the first one on the list. So same process. We have grams of ammonia. Convert grams to moles of ammonia. Moles to moles of product that I want. And now that I have moles of product, I'm going to convert that moles to grams of product. And I end up with 14.9 grams of nitrogen. Cool, that's one right there. And the other one, I have 0.145 kilograms of copper oxide. Wait, kilograms, right? Don't you have to convert kilograms to grams? Because after all, molar mass is in what units? It's in units of grams per mole. You can't really go straight into that conversion if you don't do this initial step first. You gotta get your kilograms into grams. Dimensional analysis is key, guys. Remember that unit 8. So with that said, now that you're able to convert it to grams of copper oxide, now you can do that same procedure again. Grams of your reactant to moles of reactant to moles of product to grams of product, cancel out the units, and then now you end in grams of nitrogen gas. You feel justified to crunching your numbers, sig figs and all, you end with 17.0 grams of nitrogen. Now, why is it that this first one is boxed? Is because if you compare these two values, which one is the smallest value? 17.0, 14.9. This is the smallest value. Therefore, what's going to run out first? This guy. So your 18.1 grams of ammonia will run out first, and the most that you can create is 14.9 grams of nitrogen gas. That's it. The end. You could dust off your hands, pat yourself in the back, and then wash your hands with soap and water. Good job, everybody, and we'll see you guys next time.